Hi, this is Mrs. Kidman, and in this video, we're going to be discussing how we can use the triangle midsegment theorem and apply it to finding out different segments of triangles. So first, let's talk about the midsegment theorem. So the midsegment theorem says that the segment connecting the midpoints of two sides of a triangle is parallel to the third side and half as long. So really what that means is that these two are parallel, and this is 1/2 of side AC. So whatever AC is, that's going to be half of it. Whatever that is, AC is going to be double that. Okay, so that's kind of that relationship there. So we can use this theorem to actually find side lengths of triangles really easily. So let's take a look at these first ones here. Okay, so using these triangles, let's apply that midsegment theorem here to figure out what these segment lengths are. So remember that midsegment theorem says that these two sides are parallel and these are the same, meaning that this piece is half the distance of that one. So if that's the case, what is this length of DE here is kind of what we're trying to figure out. Well, if DE is half the length of 20, that would mean that DE has to equal 10. Awesome. Okay, let's take a look at this next one down here or over here. So remember, it's the midsegment, which means that these pieces on the edge have to be the same and these are parallel. So if this side is 9, that means that X or DB is also going to be 9. Now, lastly, in this other one here, we know that DE is 7, and we want to figure out what BC is. Well, BC, in this case, is going to be double that because that's that relationship by that midsegment theorem that says it's going to be double, so we have 14. So that's kind of how we can use that midsegment theorem to apply it. Now, this last question here that we're going to go over is we want to show that DE is parallel to CB and that DE is half of CB. Now, this is really important, and it really comes into play when we do that triangle midsegment theorem proof. Now, we're using this idea that we want to prove that these two lines are parallel, and because they're parallel, we can then determine whether or not that one's half the length. So let's start by determining whether or not these lines are parallel. Well, to show that they're parallel, we just need to show that they have the same slope. So DE has a slope of DE's slope here is going to be up 1 over 1, up 1 over 1, or up 2 over 1 over 2, which means our slope of 1. And then segment CB has a slope of up 1, 2, 3, 4 over 1, 2, 3, 4. So it also has a slope of 4 over 4, which is 1. If two lines have the same slope and they are not the same line, then by definition, they are parallel lines. So that means that DE is parallel to CB. Now we want to determine that DE is half the distance of CB. So what that means is I need to figure out what DE equals and what CB equals. Now I can use the distance formula to actually calculate this. And the thing that we're going to do that distance formula is we take our Y values, find their difference and square it, and then add that to the difference of the X values. So let's go ahead and look at DE first. So this point here is going to be the point -4, -2. This point here is the point -2, 0. So we're going to find the difference of our Y values, which is 0 minus -2 squared, plus our difference of our X values, -2 minus -4 squared. Okay, so then this ends up giving us the square root of this becomes a plus, this becomes a plus, 0 plus 2 is 2 squared, plus 2 squared, which really is the square root of 4 plus 4, which equals the square root of 8. Fantastic. Okay, now let's use this same idea to find what the distance is for CB. Well, CB is this right here is the point -1, 2, 3, -6, and this one is the point 1, -2. So then we want to do that exact same thing. So we've got -2 minus -6 squared plus 1 minus -3 squared. Well, this is going to be -2 minus -6. Well, that's a plus. This becomes a plus. So -2 plus 6 is 4. So we have the square root of 4 squared plus the square root of 4 squared. And that's going to be the square root of 16 plus 16, which equals the square root of 32. Now we can simplify both of these if we want to. This one breaks down into 2 and 4 and 2 and 2. So this is really the same as 2 root 2. And this 32, we're going to break down as well. It goes into 2 and 16. 16 breaks down into 4 and 4. So we can take that 4 out and we get 4 root 2. Notice this is 2 root 2. This is 4 root 2. So this one is half of that one. And that is how we can prove that those things are true. If you're interested in the proof of why the triangle midsegment theorem works, it's going to be very similar to this idea where we put it on a grid and we use those. But instead of using specific points, we're going to use arbitrary points. So please check out that video. But again, this is how we can apply that triangle midsegment theorem. If we want to use it, first we need to check to see are two triangles, are the lines parallel? If they're parallel, then that means that they should be half that distance. If we're told that that line is the midsegment of the triangle, then what that means is that we know there's a relationship that says that the midsegment is half the length of the other one and that the two things are parallel. So it's such an applicable tool to have to be able to use this triangle midsegment theorem to help us find side lengths and different things like that. If you have any questions, feel free to reach out, and please check out the next video in which we discuss how to prove the triangle midsegment theorem.